Okay, so we'll continue our exponent and exponent rule conversation. We have the rest of the rules to go through today. So again, we'll go over the parts of a power, and we'll be doing some operations with terms that have exponents and how they behave. Let's do a quick refresh. The terminology, so a power is the whole package, the exponent is the little raised number, and the base is just the base. That's what we're going to repetitively multiply out. Okay, so 2 cubed, or 2 to the exponent 3, would look like this. Okay, so that's a refresher from yesterday or the previous lesson. These are the two rules we covered for multiplication and division. So as long as we have the same bases and we multiply powers together, then we can add the exponents. We have the same bases and we divide those powers, then we can subtract the exponents. So we're going to do one new rule today, and then a couple of variations, and we'll bring it all together. Okay, oops, I jumped those out of order. Let's bring that back up there. There we are. Okay, let's try this again. So power of a power is our third rule. So if you have something like this where you have a 2 cubed all inside a bracket to the exponent 5, that means you have 5 of these 2 cubes that are all multiplied together. And again, you probably won't do this all the time, but when you're learning, this is a great way to solve these problems, is to write them out and get used to it. And then after you've written them out a couple times, you'll be like, oh, I could shortcut here, 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 and then you get a lot quicker. Okay, so that's the first line. There are 5 groups of 2 cubes, and then each one of those groups has 3 2's in them. And if you were to write this out in expanded form, and you can see why the shortcuts start to be very important. So there's 1, 2, 3, 4. There's 5 groups of 3 there. Sorry, 5 groups of 3 2's all multiplied together. Now, you can see if we made this a 50 up here, we would not want to do this technique. It would just be, we'd be here all day writing out 2's. So there is a shortcut. So if you look here, there is a total of 15 2's all multiplied together. Okay, so now you're probably expecting there's some combination of those two terms, and there is. To get to this, we multiply those two exponents. Okay, and then this is our next rule. So the power of a power, and recognizing the difference between multiplication of powers and power of a power is one of the biggest mistakes people make. These two are multiplied, and the first rule we looked at is when they're added. So keeping that separated is a big challenge for people. Okay, so pause it here and take a shot, and then we'll take them up. Okay, so this again would be g squared 5 times. And again, if you don't need to write this out, that's awesome, but it's also not a bad technique to sort of get in the habit of checking. So that's 5 groups of those g squareds. That means there's 2 g's for every single one. So by time we multiply that all out, we would have g to the 10th. Okay, now down here we have, again, 3 to the 4th. Okay, so we would have 2 of those brackets. That means there are 4 3's multiplied together in each one of those for a total of 8 3's being multiplied together. Okay, and again, we could just check that. We could multiply those two values together, and we get to our final answer. Now, if we mix exponents and bracketed terms, okay, so sometimes fractions, sometimes other things, this can be a little visually intimidating, but please look at what we have here. We have the fraction 2/3 all to the exponent 3. That's just 3 of that bracket multiplied together. Okay, now if you focused on just the top piece right here, because we've reviewed our fraction rules, we know we can multiply across the top. Well, that's 3 2's that are all multiplied together. If we look at the bottom term, that is 3 3's that have all been multiplied together. Okay, and if we wanted to, we could go one step further and make this a 4 over 27. But what we're really interested in is this exponent went to both terms. And that's really the key piece here. Okay, so 2a all to the 5th. So that's 5 of the bracket 2a. Okay, now if you look at this, the order of multiplication doesn't matter. So could we rearrange this and write all of our 2's first? And the answer is yes. I'm just going to do it for this one question because otherwise it starts to get a little tedious. We could then have all of our a's written close to each other, and we would end up with 2 to the 5th, a to the 5th. And the key point we want to take away from this is this bracket, or this exponent, applies to both terms. That's really, really important. It's where lots of people make mistakes. So everything inside the bracket is exposed to that power of 5 on the outside of the bracket. Okay, so take a look at this one. Inside the bracket we have 3a all squared. To the exponent, all of that is to the exponent 4, which means I have 4 of that bracket. And if we look at a's, we have, 3's, we look at 3's, we have 4 3's multiplied together, so I can rewrite that as 3 to the 4th. If we look at these a squareds, we have 4 of those as well. Okay, so I'm going to leave the 3 alone for now, and I'm going to focus on the bracketed a squared term. Well, this is the power of a power again. We just did this rule. Can we multiply those two terms together and get a to the 8th? Okay, so here are your 3 rules that we've covered so far. The first 2 were from yesterday or the previous lesson. This is today's lesson. Please watch these 2 right here. People mix up all the time. All right, so let's mix them all up and see what we have. We have a cubed divided by 5 all to the exponent 5. Okay, so this starts to get a bit messy. It looks something like that. And again, while you're learning, it's a good place to write it out. Or as you get more comfortable, you'll get a lot quicker. You could then rewrite the top term would look something like that. Because you have 5 groups of a cubed all multiplied together in the top, and then in the bottom you have 5 groups of 5 all multiplied together. And then we could take advantage of our new power of a power rule. And on the top, we would have a to the 15, all divided by 5 to the power of 5. Okay, so again, we just multiplied those 2 together. Okay, so these aren't really rules, they're just really handy to know. Okay, so notice the exponent here is applied to both terms. Okay, when we have even a rational or fractional term there, and this n gets applied to both terms over here. All right, so let's mix them all up and see what we can do. Pause the video, take a trial at this. Don't be afraid to write it out in expanded form while you're learning. It's super important. Okay, so I would probably write this out like this first. Okay, now when we're working with the numbers, sometimes we'll use exponents, sometimes we'll actually just generate the values. I'm okay if we rearrange this to something like that, and then we would have a times a squared. Okay, and don't forget, these a's here where there's no exponent, there's really a 1 written there. Okay, so now we have 3 times 3 is 9, times 4 is 36. I can combine those. Those are just regular numbers. They're not powers. They don't have exponents on them, so I can just multiply those out. If I had like a cube on this term, that would change what I have, how I approach the problem, but I don't have that, so I can just multiply these guys out because they're just regular numbers. Over here, I have 2 a's multiplied by 2 more a's, and I'm left with a to the 4th. Okay, so you can see there's lots of little nitpicky rules here to worry about, so we have to go slow. Again, you can pause it and try it if you like. I'm going to write it out so you can see where all the parts come from. It looks something like that. And when I'm looking at the top term, again, I could combine my 2's into a power, like 2 cubed, or because the numbers are small, I might just multiply them together. So I might combine these 4 terms because they're all small. So 2 times 2 is 4, times 2 is 8, times 3 is 24. And then if I look on the top, I would have 1, 2, 3, plus 4, with an additional 4 a's all multiplied together. So I would have a to the 7th on the top. And then here, I would have two little problems. I would have 24 divided by 6. That's 4. Lots of people will write 18 there. Don't fall into that trap. And then I would have a to the 7th divided by a squared. That's the subtracting of exponents. So I would have a to the 5th. Okay, so now if this feels like it's going fast, it kind of is, because this stuff takes practice. If you don't practice this, it does not register. Okay, so the final two rules, one of them is super easy, one of them is a little trickier, but we deal with it more in grade 10. If we have 25 divided by 25, that's equal to 1. I could also write 25 as 5 squared over 5 squared. And if we used our exponent rules, that would be 2 minus 2, which would leave me with 5 to the exponent 0, which means these two things are the same. Okay, so let's look at one more, and then we'll finalize what we're going to do here. A cubed divided by a cubed is just 1. A quantity divided by itself is just 1. If we come over here and we do, oops, I should have done that one as the exponent first. That one will be a to the 0. These guys will all cancel for 1, and I'm left with that expression. And here's the fun, this is the fun rule, this is the easy rule. So a, or any base to the exponent 0, is 1. Always. Okay, and at first it seems really strange until you do a couple, then you go, oh, that's so easy. So 1,000 to the exponent 0 is 1. This crazy looking term down here, a plus 3b, all in the bracket to the exponent 0, 1. That's simple. Okay, so let's see if you can do it. Ready? 32 to the exponent 0. Shout it out. 1. Awesome. 10,043 to the exponent 0. 1. You got it. Oh, this crazy looking expression. Everything inside doesn't matter. As long as it's a bracket to the exponent 0, 1. That's the easy rule. Okay, so now let's just do a quick little proof by patterning. 2 to the 4th, 2, 4, 8, 16. 2 cubed, 2, 4, 8. 2 to 2. 2 to the 1. Now if you look at the pattern, are we dividing by 2 every single time? Yep, so now 2 divided by 2 is 1. So there's the rule we just proved. But now we're not going to stop there because we're on a roll. We're going to go 1 divided by 2. Well, 1 divided by 2 is a half. Okay, a half divided by 2 is 1/4, or 1 over 2 squared. Okay, and this leads into our last rule. Yay, last rule. Okay, so you'll notice this guy has a 1 as an exponent, so does this guy. This guy has a 2 as an exponent, so does this guy. What you should notice, though, is this 2 here is on the bottom. And this 2 here is on the top. Okay, so that's where we're heading with this last rule. So if we have something like 9/27, okay, if we do the regular division, we would get 1/3 if we did lowest term fractions. If we did it with an exponent rule, we would have 2 minus 3, or 3 to the negative 1. If we did this in expanded form, these would all cancel, and you would be left with 1 over 3 to the 1. Okay, so 3 to the negative 1 exponent is the same as 1 over 3 to the 1. Okay, take a second and look at that. We're going to do a couple more variations. Okay, so here's the last rule. A to some exponent that's negative n equals 1 over a to the n. And again, we do more of this in grade 10. Don't panic. Okay, it's not as bad as it looks once you see it in action. So let's take a look here. 5 to the negative 2. Well, if we compare to our rule, we would rewrite this as 1 over 5 squared. So the only thing that's changing, the base stays the same, the exponent stays the same, but the negative goes away and we write the term 1 over, and that's what changes. So we look at m to the negative fourth. It's going to be 1 over m to the fourth. Okay, that's the last rule. It's kind of a tricky one. So let's just do a couple more here. If you want to pause it and try these yourself. Okay, so this one here would be 1 over 2 to the 1. This would be 1 over 3 to the 2. And this would be 1 over 3 to the fourth. Okay, so the base and the exponent values stay the same. It's just the location of terms that really starts changing. There's a summary of all of your exponent rules. Maybe print that, take a picture, write it down somewhere, or I'll post it as a PDF on the website. You can download it. And there's some questions to try. We already did these ones. So if you haven't tried those already, that's okay. This is your new stuff. And thanks for tuning in.